Good evening, children.
Good evening.
Evening.
Good evening, ma'am.
How are you all? Please put your videos on. Keep your videos on. Everyone must keep their videos on, please. Yukta, keep your video on. Akshara, Navya. Navya Gupta, please keep your video on.
Yes.
Pranav. Okay, so children, had I given some homework to you last week? Hello? Was there any homework? Say something. Yes, no.
Ma'am, you hadn't given us homework because we had the subject objective test on.
Okay, so Saturday was your previous class, so you had
Yes, ma'am.
subjective test after that, objective test. Okay, fine. Okay, so our previous chapter was done. The linear equation chapter is done, right? We have to start a new chapter now.
Ma'am,
Yes. Yes, Rohit.
ma'am, I thought we still had some linear equation part left.
What happened? Say it loudly.
Ma'am, didn't we just start the chapter last week?
Linear equations chapter.
Yes, ma'am. The objective
Is
test.
that complete?
Oh,
The chapter is complete, I think so. We had done the graphs, we had done the questions with the value of k, we had to find out. We did extra questions also on this topic. Yes?
Yeah, ma'am, we have done this chapter.
Okay, so we are done with this chapter. Do you want more practice on this?
no, ma'am, it's fine. I thought we still had some parts of the chapter left.
It's over. You had just 2 exercises in this, and apart from that, we did extra questions also. So never mind, we will keep in touch with the previous chapter also. I'll give you more worksheets on it. Okay? Maybe in the form of homework or some test or anything somewhere. Right? Yes.
Ma'am, can you once again explain one linear equation question with graph?
Okay. Okay, I'll do that. So just take any linear equation you want to do it on the graph.
Yes, ma'am, I'm a bit confused in the graph thing.
Okay, so let's do that once. Okay, children. Let's clear the doubt first, then we'll move on to the next part, next chapter. Okay, sharing the screen now. Okay, now see, we have done so many graphs also here. Let's take an example. Okay, so today is first. 1 second. Today is first of Okay, so let's take an example. I'm taking a small example, say x plus y equals to 7. Okay. Yes, Yukta? Now see, I have just taken an equation, a very simple equation, okay, in two variables. Now, what do I want? For some value of x, I want some value of y, okay? Suppose I take one variable as independent variable and another variable as a dependent one, okay? Now, suppose if I have to find the value of y, so that means y will be 7 minus x, right? Okay, so here in this case, I will put values for x. That means x is independent variable. Depending on the values of x, y will have some of its values. Okay, so what values will it have? Suppose if I take x as 1, my y will be 6, right? Okay, if I take my x as 0, my y will be 7, right? If I take my x as 7, my y will be 0. Okay, are you understanding?
Yes,
So for some value of x, so that means this value of x is not bound anywhere. You can take any value, any positive value, any negative value, any zero, anything. Okay, so this is called independent variable. And the variable which is dependent on the value of x, that means x will decide what value to take, and depending on that, y will take its value. That means y is the dependent variable. Yes. Now I have got these 3 points here. Okay, 1, 6, 0, 7, and 7, 0. So let's plot these points on the graph. I'm making a rough graph here. But if you are doing, then you please do it on a graph paper. So, okay. So I'm taking points 1, 2, 3. My highest point in x-axis is 7. So I'll take 4, 5, 6, 5, 6, and 7. My highest point on the x-axis is 7. Okay, and this side also I'll take the points starting from 0. This is 1. My highest point here in y is 7. So I'll take 1, 2, 3, 4, 5, 6, 7, right? So this are 7 points here. Now my first point is 1, 6. That means x, when my x is 1, my y is 6. That means here. Okay. So this is the point. I'm roughly joining it with the axis. So this is the first point. My second point is when x is 0, that means x0 means here. And my y that time is 7. So my y is 0 on the line exactly. Now when x is 7, y is 0. Okay, y is 0 means exactly on the x-axis. So 7 is here. Now I have these 3 points. So I just join these 3 points with the now, and my line might not go straight. But if you join it with your scale, okay, it will be a straight line, right? Yes, children? So this is how you plot your graph, right?
Yeah.
Yes,
Yes, ma'am.
Shweta got it now?
Yes, ma'am. Thank you.
Okay, bache. Okay, now coming back to Euclid today. Okay, so I want to start a new chapter today. That's Euclid's geometry. Now this chapter is, the about the history of geometry. From where did we get our geometry? In the history, what made us to, to do the invention of geometry. Okay, this chapter is about that. There is no any, no any big calculations are there in this chapter, but the only thing is about understanding the chapter. It's interesting. Okay. Right, children? So I can see Navya here. Navya, welcome to you.
Thank you, ma'am.
Most welcome, Vijay. Akshara, welcome. Welcome to the class. Akshara is not here.
Ma'am, do you repeat the chapter's name?
What happened?
Ma'am, can you please repeat the chapter's name?
Euclid's geometry. Introduction to Euclid's geometry. Okay. I just write the name of chapter. Introduction to Euclid's Geometry. Okay, now this chapter is going to be in some story form, sort of. Okay. So what happened? This chapter is about, geometry. When we talk about geometry, geometry means geo and metry. Geo means earth. Okay. We call earth as geo. Geo means earth and metry means to measure. So the need of geometry arose when we started measuring on the earth. We were measuring the land. So that's the need of geometry. Okay. When people, used to, in the olden times, when people used to measure on earth. So we felt the need of geometry. And if you see, if you go into the ancient time, if you see the Indus Valley civilization, Harappa civilization, Mohenjo-daro civilization, you get to see those cities were so well planned in a, geometrical way. If you see their plannings, the city, the roads, if you see their houses, they were all made in so, what do you say? Even today, these days, you don't see those structures of geometry these days. Okay? Right? If you see the Egyptian pyramids, okay, we all have seen Egyptian pyramids, maybe not from near, at least photos we all have seen. Okay? Some of you might have seen actually. So, if you see, then what is pyramid actually? The base is like a square and all the sides are triangular shape, is it? So that's also an example of geometry. So did those people know about geometry? Yes, of course. They knew about geometry so well that even today the people are, surprised at how well they knew the geometry. All right? Yes, children? Do you agree with that?
Yeah.
If you see the archaeological surveys and all, you find out that geometry is something that is very ancient in the world, not only in India, but everywhere in the world. Okay? If you go back to the ancient times, as I told you,
Yes, ma'am.
Harappa civilization and all those, even before that, even if you find some archaeological things under the ground or somewhere, okay? So you get to see these geometrical structures there. Okay. Now, you must have heard about the mathematician names like Thales, Pythagoras. They were the very beginners who started with geometry initially. And later came Euclid. After them came Euclid. So Euclid came. What did he do? See, initially when people started with geometry, they didn't have any perfect rules or anything. They just did the things. There was no rules and no calculations, nothing was there. Okay. All right. So nothing was there actually. So Euclid did, he jotted down every small thing into a book form. He put everything in the form of a book and he wrote all rules for that. Now, for Euclid was the first time who gave the definition for something. Now, defining something means, suppose if we in geometry, when in the beginning, when we start studying about geometry, we always study about point. Is it? So he was the first one who first defined something. He gave a definition for something. Who gave this definition? Euclid. Okay. Before that, even Pythagoras came, Thales came, Pythagoras came, okay. Mathematician Thales also came, but they did not prove anything as such. Okay, they didn't define anything. They just worked on geometry part, but not by defining. Geometry was all scattered around. Okay, but Euclid was such a person. He assembled everything. He put it into a form of a book. What did he do? He just made a book of that. He put all those things in the book. Okay, with definition. So for that means for a point, it had a definition. For a line segment, it has a definition. If you are studying about something on the plane, it had a definition there. Okay. how do things work on a plane. So if for everything we had some definition. Definition means proven results were there. Okay. So, but all proven results came later on. But otherwise, what was that? Initially, it was, when we talk about axioms and postulates. So whatever results he put into the book he called the name elements. Okay. Whatever results he put inside the book, like suppose he said that point is something which has no parts. Okay. Are you understanding? He said that point is something which has no part. Every whole thing has a part. But he said point is something which has no part. So that means it's something general thing. Okay. It's a general thing which does not need any proven fact for this. This need not be proved. So these are called elements. Okay. And if you say a line, so line, at the end of the line, you always see 2 points. That means a line has a starting point, a line has a ending point. We call it today as a line segment. So that is also no result is required for that. No proof is required for that. So he jotted down all the things into a book form, and the name of that book was Elements of Mathematics. Okay. Elements of Mathematics. This was done by Sir Euclid. Okay. And what sort of results were there in this book? So you have some of them listed in your notebook, in your textbook chapter also. The first point, okay, we would just discuss some of those points, and you must be thorough with those points. Okay. Some axioms and postulates were there. First, we will just discuss what elements were there in his book. So first thing that he said was that a point is that which has no parts. A point is that which has no parts, right? Okay, this was the first thing he said. So does this need any explanation? This needs any explanation, right? Then second thing is that he said that a line is a breathless length. A line is a breathless length. That means a line does not have any breadth. A line has only a length. If I make a line here, so line has only a length. It does not have any breadth. Okay, the breadth is actually very negligible, right? So this was, such type of things were there in his elements, book of elements, right? The third thing he said was the ends of the line are points. If you talk about a line, the ends of the line are points. You agree to that? You agree to that, children? Hello? Yes, say something. Do you agree to that?
Yes, ma'am.
Yes, ma'am.
Why others are mum? No answers from others. I want answers from the Akshara, the new children. Akshara, Navya.
Yes, ma'am. I just said.
Are you understanding? What are
Yes, ma'am. Yes.
the elements were very common things which we see around us. Okay. Elements were very common things we see around. Okay. Like suppose we know that suppose if I give you an example, all human beings have eyes, nose, ears, legs. This is a common fact, is it? We all know that. So nothing is to be proved on this. We know that sun rises in the east. Okay. Everyone knows sun rises in the east. So does this need any proven fact? No, this is something which is very obvious. So those things were there, to which he called the elements of geometry, because it was moving around the geometrical facts. Are you getting? Yes. Are you understanding the things? Because these were revolving around the geometrical facts. We talk about point in geometry. We talk about line in geometry. We talk about endpoints of a line in geometry. Okay. But I just gave you a simple example from our surroundings, that all human beings have eyes, nose, ears, so that everyone has. Okay, nothing to be proved in that. Sun rises in the east, yes, we all know that. Nothing to be proved in this. So these were some universal facts. So same way, geometry also has some universal facts. Okay, a point has no path. A line is breathless. It has negligible breadth. Okay, right? The ends of a line are 2 points. Of course, line will start somewhere and it will end somewhere. So that means it has some definite point at the end and the starting point, right? Then the next point was the straight line is a line which lies evenly with the points on itself. Now it's saying a straight line is something on which we have multiple points. Okay, so many points can lie on a straight line. Okay, this is also a general fact. Then I'm not writing these facts now, I'm just explaining you. Okay, the next was that the surface is that which has length and breadth only. Now he said that the surface, okay, if I make some surface, I make any cubical shape here, okay, like this, some cube 3D shape here. Now it's saying, now this is the surface part of this, okay. All side it has surfaces. Now it's saying the surface has only length and breadth. Yes, of course, if I'm talking about one surface, if I'm talking about one plane area, 2D surface, it has a length, it has a breadth. That's of course it has, okay, it has two lines in the form of length and breadth. Okay, then we say the edges of the surface are lines. Of course, now 6 point also says that the edges of the surface. Now this is the surface. Now edges means these corners. The edges of the surface are lines. They are actually lines. Is it? Yes. So these things don't need any explanation. So just by looking at the things you can make out. Now, the seventh part that we said, the plane surface is a surface which lies evenly with the straight line on itself. The plane surface is a surface which lies evenly with the straight line of itself. So the plane surface is a surface which has a line on itself. Okay, we can draw any line on the surface like this. Yes, so these were some elements which were there in his book of elements. Okay. Elements of Mathematics. The book or name of the book was Elements of Mathematics. Okay, and all those elements were just a general rule. Okay, he just assembled everything and wrote it in a book with a well-defined definitions. Okay, children, have you understood this much part? Have you understood this
Yeah,
much
ma'am.
part? I want
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Shara,
Yes, ma'am. I see.
Rohit, Harshit, have you understood this
Yes,
much part?
ma'am.
Yeah, ma'am.
Okay, so we'll move ahead. Okay. Okay, now coming to the axioms and the postulates part. Now he said, the Euclid. Okay, Euclid said axioms are some things. Axiom will talk about axioms and postulates. And this is something very important in this chapter. Okay, इस चैप्टर में अगर कुछ important है तो वो axioms and postulates है. Okay, so this should be, should be on your fingertips. Now, what should be on your fingertips? I'll let you know now. Axioms and postulates. Now, listen first. What are axioms? Axioms and postulates are actually assumptions. This is not a fact. These are assumptions which are universally people have agreed upon it. Okay, these are assumptions. Okay, so you will write here for axioms, assumptions throughout mathematics that are obvious and do not need to be proved. Okay, assumptions, please write down. These are assumptions. Okay, assumptions means we are assuming something, we are imagining something. Assumptions throughout mathematics. Throughout mathematics means everywhere in mathematics. So if we say maths is all around us, that means axioms are everywhere around us, right? Assumptions throughout mathematics that are obvious, and do not need to be proved. This does not require any proven fact. Okay, axioms are assumptions throughout mathematics that are obvious and do not need to be proved. Okay, so that means it's throughout mathematics, it's universal. Now postulates. First write down, I'll give you examples of this. Postulates. And postulates are again assumptions. Postulates are also assumptions which are specific to geometry. Assumptions specific to geometry. Now here it was said these were axioms were assumptions throughout mathematics. But this is postulates are assumptions which are very specific to mathematics, geometry only. Specific to geometry, right? Specific to geometry means something which is moving around, something that is talking about geometry only. Okay, so assumptions that are specific to geometry, assumptions specific to geometry that are obvious, and do not need to be proven. Do not need to be proven. Okay, proven or proved. Yes. So can you see the difference here? Assumption throughout mathematics. Now throughout mathematics, if I have to say means, suppose I'll take this some examples of, if I have to take some examples of axioms now. Now let's see. In your book, you have some 7 axioms given, and all these axioms should be on your fingertips. All 7 axioms are there, right? Now, what is the first axiom? That means it's assumption throughout mathematics that are obvious and do not need to be proven. Obvious means something that is a universal fact. Okay. Here also obvious word is written. That means it's a universal fact. Okay. You understand, no? What do you mean by universal fact? Yes, children. Universal fact means that everyone and everything agrees to it. Something that is agreed upon universally. Okay. So let's see the first axiom of this. Things that are equal to the same thing are equal to one another. So I'm not writing the full big sentence. It's all there in your book. Do you all have the book? Or should I write? Okay. Things, it's saying things which are equal to the same thing. I'll explain you what does it say. The book languages are sometimes, not easily understandable. The things which are equal to same thing are equal to one another. Now, if I have to take an example of this, I say that one child has got in the test, one child has got 40 marks. Okay, child A has got 40 marks in the test. Child B also got 40 marks in the test. So can I say that child A and child B both have got equal marks? Can I say that?
Yes, ma'am.
Yes, ma'am.
I can say that. No, it's a universal fact. Nothing to be proven in this. Okay. If child A is getting 40 marks in the test, child B is getting 40 marks in the test. So I can say that child A and child B both have got equal marks. That's all, but something that is very obvious, is it? So this was one axiom of that. Okay. You will see now where we use these axioms in our everyday mathematics. Okay. We'll see that later. But first, just understand about the axioms. So things which are equal to the same thing. Okay, now A was getting marks B was getting marks 40. So things which are equal to the same thing are equal to one another. That means if two things are equal to one thing, that means they both are equal. Okay, they are equal to one another. I hope you have understood this. Okay. Now second axiom is that the equals are added. If equals are added, if equals are added to equals, the wholes are equal. Now, what does this mean? If equals are added to equals, now I'll go with the same example. Now, suppose if child A has got 40 marks, okay, child B has got 40 marks, and if I become very happy with their performance and I give them 10 marks extra. Chalo, wait, extra ho gaye unko marks. That means to A also I give some extra marks, to B also I give some extra marks. Okay, 10 marks मैंने उनको extra दिया. That means if equals are added to equals, they were already getting equal marks, and I have added equal amount, okay, to their number. So the wholes also become equal. Now their total becomes 50 and 50. Are you understanding this? If equals are added to equals, the wholes are also equal. Is it? If I add equal amount to one thing and equal part to another thing, that means they will again become equal only, no? Okay, that means again A and B will be equal only. Yes, are you understanding?
Yes,
Please unmute and see something. Yes, no. Otherwise, I'll explain the same thing
Yes,
again
ma'am.
if you've not understood. If you don't want to say, then please show thumbs up. Do something, no? So that I get to know you are understanding. Okay? Do that, please. If I'm asking something, so do that. Okay. Now see the third one. The third axiom is that if, I'll just write here, if equals are subtracted, if equals are subtracted from equals, the remainders are equal. If equals are subtracted from equals, the remainders are equal. So now let's see with the same example. Now A got 40 marks in the test, B also got 40 marks in the test. Now if I have become angry with them, so I will subtract for 10 marks of theirs. Okay. मैं क्या करूँगी? I will subtract 10 each from their marks. So from A also I have subtracted 10 marks, from B also I have subtracted 10 marks. That means I have subtracted equal number from their marks. So they were already equal. I have subtracted equal amount from their part. So that means they are still equal. A and B are still equal only. Yes. So if equals are subtracted from equals, the remainders are equal. Remainder means the answer still remains equal. Okay. If I subtract 2 from 5, and if I subtract, if suppose 5 is here, 5 is here, this side. If I subtract 2 here, this side, 2 here, this side, the answer will be again equal only. Okay. Yes, children?
okay, ma'am.
Okay.
Yes, ma'am.
Now, I hope you are understanding these axioms. First, understand these axioms and we'll see where are they applicable. Okay,
Yes,
how do
ma'am.
we use them in our day-to-day sums, right? In our theorems and all. Okay, now see the fourth point. Things which coincide with one another are equal to one another. Things, you can even note down these things because all these axioms should be on your fingertips. Okay? Because the kind of questions that you get in your exams, they ask you which axiom is applied in this question. So you have to mention which axiom is applied. So you will not write there number 1, number 2, number 3 axiom. You have to write the full statement of the axiom. Are you understanding? Are you understanding, children?
Yes, ma'am.
When in the question you are asked to which axiom follows here or which postulate follows here, then you have to write the statement of that axiom or that postulate. So you cannot just write axiom 1 or axiom 2 or no one knows what is 1. Okay, so don't go with the number. You have to learn these statements. Okay.
Yes, ma'am.
So, and there are specifically marks for this because the question actually asks this, which axiom follows here. So you will have to mention there which axiom follows here. Okay. So now see the fourth one. Things which coincide with one another are equal to one another. Things which coincide. Coincide means something that overlaps. Is it? So things which coincide with one another are equal to one another. Now, what does this mean? Now, suppose if I have a circle, okay, and I take another circle, I have a circle made of cardboard, say, okay, I have a cutout of a circle. I have another cutout of a circle with the same radius. So things which coincide with one another are equal to one another. I take one circle and one circle. I'll keep one on top of them. Okay. If I keep this circle on this and it completely overlaps it like this, then I'll say that the circles are equal. Yes, can I say that? Things which coincide
Yes,
with
ma'am.
one another are equal to one another. Of course, when they are overlapping each other and nothing remains extra or less, that means they are equal. Okay. Now, fifth postulate is that the whole is greater than the part. Okay, we all know that the whole is greater than the part.
Yes, ma'am.
Okay. So suppose if I have an apple here, okay, and somebody takes a bite of this. So I have taken out a fraction of this. So this, it says the whole is always greater than its part. This big apple is always greater than its small part. Is it? Yes. So whole is greater than the part. So that's obvious only. So now things, sixth axiom is that there are 7 axioms. Now we have come on the sixth one. Things which are double of the same things are equal to one another. Now what does this mean? Things which are double. Things which are double of the same things are equal to one another. Things which are double of the same things are equal to one another. Now suppose A got 40 marks in the test. B also got 40 marks in the test. Okay, if I make their marks double, 40 plus 40 is 80. Here also I double the marks, 40 and 40, that's 80. That means again they are equal. They are equal to one another. Is it? So things which are double of the same things are equal to one another. You got it? Yes, children? Hello? Hello, can you hear me?
Yes, ma'am.
Okay. I hope you are understanding this. Yes,
Yes, ma'am.
Guys, videos
Yes,
are gone off. Please keep your videos on. Okay, now see the seventh axiom. Things which are halves, things which are halves of the same things, things which are halves of the same things are equal to one another. Are equal to one another. Now, अब तो आपको ये समझ आ गया होगा. Double वाला समझ आ गया तो it's exactly the same. Now, if A got 40 marks in the test, B got 40 marks in the test. If I reduce their marks to half, okay, 40 minus 20 is 20. 40 minus 20 is 20. So that means again they are equal. Yes. Things which are halves of the
yes,
same
ma'am.
things are equal to one another. Yes.
Yes, ma'am.
All right. So these were the 7 axioms. Okay. So what are axioms actually? Just now we said these are assumptions. Okay.
Ma'am, throughout the
Throughout
mathematics,
that
throughout the
are
mathematics
obvious
that are
and do not
obtained
need
and
to
need
be
to be
proved.
proven.
So did you understand what are these assumptions
Yes,
throughout
ma'am.
mathematics? So these were very common facts. किसी दो बच्चों की marks अगर total equal है, so if I give them extra equal marks, then again they will be equal. If I reduce extra equal marks, again they will be equal. If I increase double of their marks equally, double of their marks, they will again be equal. If I reduce their marks half, again they will be equal. If I coincide a figure with another figure with the same radius, same measurement, everything, that means it will be equal again. Okay. Are you understanding? If I have a square with each side 4 centimeter and I have another square with 4 centimeter all sides, and I keep one on top of the other, that means they will be equal again. Their area will be equal again. Okay. Then I know that whole is always greater than its part. We all know that. Okay. A whole thing is always greater than its smaller part. Right? And things which are equal to the same thing are equal to one another. Okay, if two things are equal to the third thing, that means they both are equal also. If this is equal to this is equal to this, that means they both are also equal to one another, no? Yes.
Yes, ma'am.
So have you understood all the axioms? So what are axioms you have understood now? Okay, assumptions throughout mathematics that are obvious and do not need to be proved. So these were the axioms and these do not need any proven fact, right?
Yes, ma'am.
Great. Now coming to the postulates part. What do we see in the postulates? This is again very important thing. See, all the 7 axioms should be on your fingertips, right? These are all the 7 axioms. You must learn these axioms, okay? And wherever you get them in your questions, it's always asked which axiom applies here, which postulate applies here, and using that axiom, prove this, using that postulate, prove this. Such type of questions you will get in this chapter, right? Don't worry, they are not any difficult. It will be very simple questions are there. Okay, now coming to the postulates part. Now, before we move to the, okay, let's move to the postulates only. We'll discuss other things later. Okay, that's now postulates. Now postulates, what did I say? That is again an assumption which is very specific to geometry. These are assumptions which are very specific to geometry and still they do not need any, they do not need to be proven. Okay, these are some very obvious facts which need not to be proved. Okay, but they move around geometrical things. Now, 5 postulates are there. Okay, how many postulates are there? 5 postulates are there and there were 7 axioms. Okay. One second, just a second. Okay, children, we'll take the postulates part tomorrow, right? Because it's time up. I didn't realize the time. The students of other class
Yes,
are
ma'am.
calling. Okay?
Yes, ma'am.
Okay, so please go through the axioms part. If any doubt is there, you can get back to me. Okay, we'll continue with the postulates in the next class. So thank you for today. Thank you to all. Bye-bye. Again, I'm getting another call. Okay.